Thank you, everyone. Good afternoon, and welcome to this BetterBev webinar. I'm John Fay, a project manager at New MOA. I have the pleasure of helping to coordinate the regional BetterBev project through an EPA subaward from Rhode Island DEM. I will be the moderator today. This webinar will focus on a case study done in Rhode Island on an organics collection program by a local food waste hauler, Remix Organics. In the craft beer brewing process, several organic byproducts present a collection and recycling challenge to breweries and can create issues that flush down the drain. This webinar follows how Remix developed a practical system for collecting and recycling these byproducts. Later this month, we will hold a second webinar on using a recognition program such as BetterBev to improve and expand pollution prevention work done by states or nonprofits or other groups. Both webinars will be recorded and posted on the BetterBev website, which is betterbev.org. Before we get started, I'd like to review some housekeeping details. Please note that this webinar is being recorded and transcribed by Teams. Please keep your microphones on mute during the presentation, and the presenters will take questions at the end. We also encourage using the chat for comments and questions, and you can do that along the way. My colleague here at NMOA, Stephanie Frisch, and I will be monitoring it and bringing questions to the speakers at the end. After the presentations, we will take questions and comments also via chat or opening up the microphones. Okay, go ahead and start the slides, please. Our presenters today have been doing fantastic work improving the sustainability in the craft beverage sector for years. Luke Truman comes from us from the New England Environmental Finance Center at the University of Southern Maine. Luke has worked as both a brewer and a pollution prevention specialist for well over a decade. And we also have Jeremiah Traub. He's the business manager at Remix Organics, a food waste hauler in Providence, Rhode Island. Remix has been diverting solid food waste from the landfill since 2013 and has diverted over 42,000 tons of solid food waste. Starting in 2021, they were asked to help recycle high-strength liquid organic waste from 2 breweries in Providence and have recycled an estimated 190,000 gallons since, with 65,000 of that occurring just so far in 2025. So let's see. And I'll introduce BetterBev, and then I'll send it on to Luke and Jeremiah to fill in the details. BetterBev is a multi-region collaborative effort. It started in Region 1, thanks to Region 1 EPA and some cited folks there. And it essentially is leveraging the work that's been done in states and at universities in New England, and actually have broadened it on to Region 3 and Region 4 also of the EPA. So it is working to support craft beverage manufacturers. So broadly, craft beverages, breweries, wineries, cideries, kombucha makers, and other craft beverages. And it's a pollution prevention effort trying to promote efficiency in production, worker health, environmental performance, all those sort of things. There are many aspects to what BetterBev does, including direct technical assistance, looking at chemical alternatives, process changes, ways to use chemicals in safer and more efficient ways. Also, there's a lot of knowledge sharing going on between the different groups Each different group has different strengths that they can bring to the process, improving the pollution prevention efforts of everyone who is a member or a partner. And lastly, we also have, and very importantly, our Green Craft Recognition Program, in which craft beverage providers can actually get recognition and for their sustainability efforts so far. And we've got several dozen already recognized facilities or makers in New England and beyond. We have some as far down south as North Carolina. And we've developed an assessment form, which is essentially like a checklist where a brewer can do a self-assessment or with the help of technical assistance from BetterBev staff to kind of go through all their different efforts to reduce their materials use, to reduce their energy use, reduce the water use, and other sustainable practices. And if they go through this process, they can become recognized. And one of the aspects that was important to BetterBev was to have a logo and a presence. So we actually had a professionally developed logo, as you see on the right, and brewers can put it on their packaging up in their tasting rooms and tout it on their websites because they've earned that recognition. So that's kind of the basics of what BetterBev is doing. And you can always go to betterbev.org to see all the details. There's a lot of resources for brewers on the website for anyone who's looking for particular help on a particular topic. All right, and with that kind of introduction, I'll turn this over to Luke to dig in more to the details of this particular case study we've been working on.
Yeah, and actually, Jeremiah, why don't you talk a little bit about Remix first?
Absolutely, thank you. So who is Remix? Remix Organics provides logistics services to recycle organic waste for commercial businesses. So we started in 2013. Since then, have grown to a fleet of customized collection trucks collecting solid food waste from generators like restaurants, schools, universities, and then we work with both partner compost farms that recycle the solid organic waste and turn it into compost, or the anaerobic digester in Johnston, which turns it into renewable energy. So you can see our customized collection solid truck there in the middle, and a compost pile with a clean load being dumped there. And then recently got our new vac truck. So came on board the end of July. First month of operation was the month of August. You can see that on the left there. And that is the first tote collected at Tilted Barn Brewery last month.
Awesome, thank you. So I think before we really dive into this topic, it's really important to understand why these materials from the brewing industry are get the attention that they get, and why Jeremiah and Remix were inspired to develop the processes they did to service the industry. And it's worth noting that the materials themselves are typically high in biological or biochemical oxygen demand, as well as total suspended solids. So they require a lot of oxygen in order to break down the organic matter, and they have a lot of particulate matter in them. So when you're thinking about a wastewater system, the bugs necessary to break down the material, the BOD can really disrupt operations. Total suspended solids can cause trouble elsewhere. And you can see on this picture to the right, a check valve in Portland, Maine at a pump station getting jammed up with brewery waste. So it's one of those things where you've got the treatment piece, but then also the systems in the breweries themselves, and then everything between a brewery and the treatment facility. So to think about the BOD levels themselves, a huge shout out to Portland Water District for doing a bunch of lab analysis for us to take specific materials and determine the BOD levels and concentration. These are approximate levels. It's going to change depending on what you're doing, but the typical household waste being roughly 300 milligrams per liter. If you're talking about the materials that Jeremiah's specifically handling, which is yeast and trub combined, you're looking at 400 times the strength of that. So in concentration, they can cause a lot of trouble. And you'll notice that one thing that we haven't been mentioning, which Remix and Jeremiah do handle some spent brewery grain. It's not listed here because there is a valuable outlet for that. It's typically used as livestock feed. And so most breweries can partner up with a farmer that has livestock, and they'll come and pick that material up for free. It is worth noting that if not managed properly, so say stored outside uncovered or in leaking bins, in the table on the left, the bottom row, so weak wort, that's the stuff that's going to be leaking off of that grain onto the ground. And so if it goes into a storm system, compared to household waste, it's a really, really strong material when it comes to BOD levels. So some of the work we've done is to determine how much of these materials are being produced per barrel produced at a brewery. The target facilities that we're working with are small producers, so you're going to wind up with more material per barrel than, say, an Anheuser-Busch or even an Allagash Brewing. But we're looking at, the generation of the individual materials, your hot side trub, so spent hops and proteins that you're actually going to generate through the boiling process and separate from what is called wort, so the sugary liquid that becomes beer once it is fermented out. So that's the hot side trub. And then spent yeast, so much like a wastewater treatment plant, when you make beer, you're going to generate more yeast. So in a wastewater treatment plant, you generate sludge. So spent yeast is no different. There is no way to make beer without producing extra yeast to dispose of. And then the cone bottoms themselves, and Jeremiah will get into some of the specifics on the trouble with dealing with these materials. But anytime you have the hops mixed in with the yeast, especially the what would be pelletized hops, so very granular, as it settles out, it becomes pretty difficult to deal with. Whereas spent yeast is pretty fluffy and a lot easier to deal with if it's by itself. But to be able to provide value to the breweries and make it as convenient as possible for everybody involved, it's good to mix these materials. So looking at the Rhode Island brewing scene, Remix operates in kind of greater Rhode Island. Jeremiah can talk a little bit more about that. You have, as listed on the Guild's website, about 36 breweries in Rhode Island, producing a total statewide of roughly 100,000 barrels of beer a year. To put that into context, the biggest brewery in Maine is producing probably more than 100,000 barrels of beer a year currently. So it ends up being, quite a small amount of beer per brewery, but collectively it becomes a significant amount of beer plus the potential of material that can be side streamed that is clean and PFAS free, ideal for anaerobic digestion and compost. And to think about the treatment of BOD, so typically, or that it's accepted that a pound of BOD treated generates half a pound of sludge. And so in thinking of this entire quantity at the strengths that we're looking at, you're talking, 312 tons of sludge generated if 100% of that material was to go down the drain and be treated at a treatment plant, plus the solids involved that aren't treated, turned into sludge, labor, energy, chemicals, disposal. So it's kind of the I suppose bottom of the pyramid as far as value is concerned, when these materials are put down the drain. And yeah, Jeremiah, do you want to talk a little bit about the beginning of this effort?
Yeah, thank you. So in 2021, two local Providence-based breweries, Narragansett Brewery and Long Live, reached out to us and asked if this is material that we could recycle. We jumped at the opportunity to participate, would try to help find a solution. So all of our food waste, for the most part, is collected in 48-gallon toter bins. They're rated to hold 300 pounds, and they weigh typically 250 to 300 pounds full. That's with solid food waste. So putting liquids in there and having them full is different than solid. So trying to lift it up, our customized lifter on the truck, it was spilling all over the place. So then they could only fill them like halfway. Still was making messes, splashing in the dump bed. So quickly pivoted to that container is good for solid food, not for high strength liquid waste. So there's a plethora of food grade 275-gallon IBC totes that you can get pretty easily and inexpensively. So we switched to that receptacle for them to collect their high strength waste shortly thereafter, and set up on a swap program. So we would come pick up a full 275-gallon tote when they had it full, and we drop off an empty one. We would take that back to our shop in Providence, and then we would empty that with a forklift into the back of the route truck and mix it with solids. So it was not all liquid in there. So we used this kind of model as proof of concept. We applied for a Swiffer grant with the City of Providence that the EPA funded, and were awarded the grant, and decided to allocate a large portion of the Swiffer grant to purchase a vacuum truck to more efficiently handle the liquid waste. So phase one, as I was mentioning, these are the 48-gallon toter bins. Great for food waste, not so great for liquid. They get heavy, messy, and they're designed to hold solid food waste, not liquid. Pivoted from that really quickly. As you can see there, the picture on the left, that's the IBC tote that was full, lifted with the forklift, emptying into the back of our truck. We went through many iterations of trying to find a way to get the solids reintroduced into the liquids. As Luke was explaining, you can see a picture there in the middle. The stuff can turn to just mud, and you need either a ton of water to break that back down, or high power vacuum, which gets most of the material out and minimizes the water. So we created some air compressed paddle wheel mixers, some manual stirrers, a bunch of different tricks and tools to try to get those solids back into a liquid state. And then it would go out. There's you can see a 2-inch drain valve on the bottom on the picture on the right there. And without horsepower, trying to get solids to turn into liquids and go through there just through gravity was not efficient, used a ton of water, and very time consuming and cumbersome. So as we continued to capture more material with more generators looking to side stream their high strength waste, the vacuum truck became the next logical step in being able to offer an efficient way to manage the material. So the vacuum truck has negative 20 psi vacuum pressure, which can pull a lot out. You can see we can hook a hose right up to that bottom 2-inch port. There's a little cam lock that locks on it. We turn the vacuum on. And this last month, as we've been trying to figure out how to mobilize the vac truck to go out there, we've been processing the majority of them in our shop, and found that 60 to 80% would come out with the initial vacuum, and then trying to find new tools and minimize the amount of water to get that last 20% or so solids to get vacuumed back out. But significant improvement with the efficiency process, less water use, and now is the trick of mobilizing all of the tools on the truck so that we can have it out in the field. So yeah, we obtained a 1,900 gallon vacuum truck, got possession this July, got it licensed on the truck in August. This just allows us to efficiently manage this waste stream, as well as accurately track what we're collecting, what we're disposing, and how much water we're using to extract the material out of there. Previously, it was a big giant guesstimate, and now we're starting to track detail information of how much is coming in, how much we're using, and how much is going out. We're excited about the opportunity to expand partnerships to recycle more liquid organic waste. Since 2021, estimating about 190,000 gallons recycled, with over 65,000 gallons just this year. In August, we set our new benchmark for 59 IBCs that were recycled, and we're currently working with 8 breweries here in Rhode Island, one in Connecticut, as well as a cheese manufacturer that had some issues with their wastewater treatment facility processing their high BOD. So currently all the material is going to the anaerobic digesting plant in Johnston, operated by Energia. And then we do take some material to Earth Care Farm in Charlestown as well. So the takeaway, this IBCs are super convenient for the brewers. So they can store a significant amount of small brewery waste. Some of the breweries fill up an IBC every 2 weeks. Others are filling up 4 or 5 a week. Either way, they're easy to move, pallet jack or forklift. You can move them around wherever you want, store them outside, out of the way in the back of the brewery. They're sealed. There's a ball valve on the bottom export 2-inch, which every time we find one leaking, we swap it out, but they happens pretty minimally. The top has a air vent port valve on the 6-inch, so the bubbling chemistry that's happening in there, the air pressure can vent out and they don't blow up. So the equipment is elevated, so it's easy to move around and collect materials and not have to lift anything heavy. And using techniques such as vessel pressure to move the materials into the IBCs can save a lot of labor and water. Side streaming the material can reduce wastewater costs and protect septic systems. As well, side streaming material to the digester or composters really realizes the true value of the material and puts it to a better use. The convenience for us, the IBCs are scalable. We have about 45 IBCs right now that are in rotation with the 8 breweries and the cheese producer we're working with. They work for all different sizes. Again, we can drop off 8 IBCs or 1 IBC. We can get you set up for once a week, twice a week collection, or every 2 weeks. So we're in the process of trying to build an efficient milk run where we can just have the mobile truck out there collecting the material on site. And the more generators that sign up for the service and want to put their high strength waste to a better use, we can efficiently build routes around that to save efficiency and recycle it more easily. So the vac truck saves a ton of labor. We're still trying to measure that, but I can tell you it's night and day difference. The difficulties of managing this material it's challenging. The liquids separate from the solids, and you just end up with a big pile of mud. So we're excited about having to be able to take it directly from the generator to a processing facility, whether it be AD or compost. The vac truck purchase cost can be supplemented. Case in point, local, state, or federal foundation grants. Super appreciative of the opportunity we were to get to have this piece of equipment. And the system can be replicated and allow for expansion to other high strength watery byproducts such as cheese. I didn't even know there was such a thing. And next thing I know, I picked up 2 cheese totes this morning. So yeah, it's convenient, efficient, scalable, and we're excited to be part of the solution to put this material to better use.
Awesome. Yeah, and so, a good way to look at this project and kind of the approach that Remix has taken and the efforts that BetterBev has put into play. And, this project is in its infancy stage, really. Like if you think about how many breweries Remix is working with and how much potential additional materials just from the brewing industry, that added to the other food manufacturers that are generating liquid waste. There's just a ton of potential here. And it's worth looking through the regulatory lens, like how to think about this material differently and how to think about the value that can come from public-private partnerships when it comes to, incentivizing best practices and getting funders in relationship with service providers and the producers of the materials, and thinking about, the resource value itself. I like to think of the side stream materials from the brewing industry as food, essentially, and to think about the way that we manage food waste and food waste bans and not, we're trying to reduce the amount of material going to landfills. We're trying to realize the value of that material. And this is a perfect example of taking advantage of what's out there and looking at it through a different lens and trying to take the incentive approach versus a bit of a stick approach. And rather than, relying exclusively on surcharges to influence practice, if there can be more efforts to think about, the long-term community benefits and the number of tangents that can also benefit the community, this project not only allows Remix to increase their services, their workforce, but then when you think about what's happening with the materials beyond that, bringing extra resources to the digester, bringing more valuable, compostable, clean, organic material to be field applied or bagged as compost. Like there are just so many ripple effects that are positive that can come from a project like this. And your end results are the same as going through a more punitive approach. And this tells a much better story, frankly. So to think about it through the incentive approach and partnership approach, and then to look at the industry, I feel like anytime I talk about wastewater and talk about the brewing industry, it's important to acknowledge that industry specifically, and one thing that really excites me about working in the industry and beyond supporting the industry is just that the value that the craft brewing industry brings to communities as ad hoc community centers and the just dollars that breweries bring to a community are massive. And in Rhode Island, $265 million of Rhode Island's economy comes from craft brewing, and that's only 100,000 barrels of beer a year coming out of that industry in Rhode Island. Like, it's a drop in the bucket quantity wise and a massive impact economy wise. So, the number one thing that I hear about from breweries has to do with wastewater. And one of the biggest concerns I hear about from municipalities has to do with wastewater from breweries. And this is an example of something that can easily solve a problem or a perceived problem without potentially shutting down or making it so that a community wants to attract a brewery and figure out how they can partner and get a brewery into a community to bring all of the value that a brewery adds. And with that, I'll jump off my soapbox.
Well, with that, also, I want to give a big shout out to the City of Providence and to EPA Region 1 for funding the Community Swiffer Grant to Providence. They obviously saw exactly what you were just talking about and in being able to support this partnership with Remix. So big shout out to Region 1.
Yeah.
And they do have a second round coming of Community Swiffer grants. So we'll look forward to seeing what sort of winners or awardees come out of that program.
Sweet.
All right. And with now we can just open up to questions and answers and a little discussion time. I'll be checking the chat, and I've dropped some of my own questions in there, but we have some other ones coming in. Please feel free to either raise your hand and then turn on your mic when you're called on, or I can read from the chat, and I'll go ahead and start reading. We have one question from Kevin Proft. Is the cost of remix hauling less than what a brewery might otherwise pay in sewer fees?
From my understanding, it depends on what wastewater treatment district you're in and what capacity they can handle the material. And as Luke was referring to, what surcharges they would impose. So it varies depending on where the brewery is located and what wastewater treatment facility they're hooked up to and what the amount that wastewater treatment facility can process. So some instances I would say absolutely, other instances maybe equal, other instances maybe not.
And would it, I know some breweries are not in an urban area, so they have to either have holding tanks or put it into a septic system. And that's a whole nother cost.
Yeah.
So
I would say we're comparable with what a septic pump out would be. So cost neutral at that point. And we're eager to gain more material, and more efficient we are, we're happy to pass along that cost savings from the efficiencies we gain back onto the waste generators.
And it's worth noting there, John, that any time a septic tank is drawn down, that material is going to go to a wastewater treatment plant. So being able to collect it and divert it to a better cause for the same price is, going to be a much greater benefit.
Right. Very good point. It's just going to end up making that half pound of sludge for every pound of BOD. And as Maine knows, there can be issues with spreading wastewater sludge on farm fields. I have another question here from Paula Jewin. I manage the anaerobic digesters at wastewater treatment plant in Lewiston, Maine. And we take true waste from a local brewer, but would love more. We're about 30 minutes north of Portland. Would love to connect with the right folks to talk about this. That's fantastic. And I guess I would, before I turn over to you, Luke, because you're a Mainer, but the guilds or brewers associations in each state are fantastic resources. And Jeremiah, if I'm right, it's kind of the information sharing and communication that the Rhode Island Guild developed over the years helped Narragansett and Long Live think, hey, let's do this together. Let's connect with Remix.
Yeah, the Guild's amazing group of collective people where they're sharing ideas about everything brewing and how to make better beer and be more efficient and use less resources and generate more revenue and be more efficient and recycle their organic waste. So yeah, I'm assuming most of the other guilds are in similar lane.
Yeah, absolutely. And speaking of which, Paula, I serve on the Maine Brewers Guild's technical committee, and I can definitely follow up with you and connect some dots there.
Terrific. All right, I'll keep looking for questions. I've got another one too. Jeremiah, this system looks a little different than your swap out system in that you may just pump out an IBC and then leave it there with the brewer. Is that going to be an issue because are you washing them at the end, or do you think there might be an issue with just leaving the same particular IBC there?
That's what we're in the process of figuring out. So at this point, we've only done a handful of on-site collections. We're still swapping the totes, and we're collecting them in the vacuum truck at our shop and trying to figure out how to mobilize both a way to resuspend the solids into the liquid on site, as well as figure out a way. There has to be some sort of water. We don't want to leave it 20% full of the mud. So there has to be some water to get the rest of that out and try to get it as clean as possible. So we are not going to switch over to a completely mobilized collection until we're confident that we have a mobilized version of what we do at the shop that can go out on site and perform.
Right. Okay. And have you tried both the suction from the 2-inch valve at the bottom and going in with your pipe in the 6-inch over the top?
We have. So the benefit of the bottom we found is it's pulling the liquids from the top through the solids. So you capture more of that initial pull. When we were coming from the top, it just created a mud corner and the center was empty. So it's slightly faster with the 3-inch hose coming from the top to pull that initial, but then you're left with more solids you have to try to figure out how to manage to get back out. We have an adapter coming that'll hook the 3-inch hose to a 2-inch port, which will give us a little bit more suction power. So we're hoping that can get another little notch of efficiency in the process.
All right. Well, it's very new, so you're shaking it out.
Yes.
All right. Do we have any other questions? All right. I've got one more question oh, go ahead, Luke.
I would say as this project develops, so I think that it's kind of, been piloted, right? We've demonstrated, or Jeremiah has demonstrated that it's got legs. The industry wants it. There's a ton of potential for growth. It would be worth getting to a point where it's like, all right, we're committing to a 10-year timeline here, right? And thinking of different holding containers that are similar to IBCs, cheap and rugged, but maybe conical. So something that isn't a flat bottom. I had been in a brewery for a lot of years that had a modified dairy tank essentially for these same materials, and we had the same problem, but just on a much bigger scale. And if you were to do, something that's shaped differently, where those solids aren't going to have the ability to really cling to the sides in the same way that they do in those IBC totes, it could be, time wise and as the funders continue to see the value of this approach, it could be a way to really increase that scale just based on strictly on efficiency.
Absolutely.
Yeah, for instance, I'm thinking about the fermenting tanks that have the cone bottom to them. I wonder if something like that would be more efficient or not. I have no idea. So, yeah.
Yeah, and if you think about the way that a silo is built, right? Either for solid or spent grain, they are shaped conical in the same way for the same reason.
Yeah.
Oh, right. All right, Shaylin, go ahead and unmute and ask your question.
Hello. I have a couple questions. So you just mentioned those fermentation tanks. I have one brewery for sure that side streams into an IBC tote, but has recently started, when they're able and have an available fermentation tank, they'll also use that as their collection for wastewater. Is that something that Remix could come in with the vacuum truck and like hook up to? And
I would assume so. Yeah. So we have a 2-inch and a 3-inch hose, and depending on what the size of the fitting would be on that tank, the hose is 75, 80 feet long. So the truck could stay outside and you could just pull the hose in and connect it up and turn it on. And yeah, the conical shape and gravity, I'm assuming would make it much more efficient.
yeah, awesome. That's
Yeah,
definitely some info I can pass along. And oh, sorry, go ahead.
sorry to interrupt you. The main thing you're going to want to make sure that you're aware of there or thoughtful about is just making sure that you have enough makeup air to account for that 20 psi draw at volume, just so you don't implode the tank.
Yep, fair enough. And I don't know if you can answer this question, but I was just thinking, if a lot of breweries are that normally would discharge to the sewer through basically their floor drains or, something like that is, and they're starting to move towards this side streaming collection. Have any of the municipalities that you've talked to had those breweries kind of like plug up their floor drains, like just to make sure they're not discharging to the sewer anymore?
We haven't specifically had any wastewater treatments that reached out to us with this problem. I know there was a couple of other instances where it wasn't the solids, but the BOD kind of was at a super high level and wreaked havoc on a wastewater treatment facility. And then at that point, the brewery was up against high surcharges and high cost of implementation of monitoring and a bunch of stuff. So he found our costs significantly more reasonable to be able to continue to brew beer, as opposed to close his doors because he wasn't able to offset the cost of what he would have had to do.
Right.
But we have not had any specific wastewater treatments reach out and drive people to us. Most have signed up for wanting to just do it.
Mm-hmm. Yeah,
Yeah,
definitely sounds like a better alternative. Thank you. I appreciate it.
yeah, and to add to that, you've got the materials that Jeremiah is taking are a component of what makes up that wastewater. And if you were to expand, so I showed that table that had the BOD levels based on material. One thing that I didn't call out specifically in there was beer, which a 6% beer has a BOD level of 100,000 milligrams per liter. That's another one of the potential materials that can be side streamed. So I guess what I'm getting at is you could feasibly at a brewery separate all of the highest strength materials, but still have some water that could go to a wastewater treatment plant that needed to be minimally treated versus the water that includes all of this high strength material. Because you have, in a brewery, the best performing breweries in the world, like the Anheuser-Busch's, are going to be using 2.5 gallons of water for every gallon of beer that they make. And so, and that just goes up when you're talking about smaller brewers, and can be they can be significant water users, based on the amount of beer that they're making, comparatively. And so you're gonna, like, if you expect to be able to side stream 100% of the wastewater, including all of the high strength materials, like it can turn into a pretty big cost unless they are, teeny weeny and extremely water frugal. So just something else to consider there.
Thank you.
We did also, one of the partners we're working with, they are on a septic and they've seen a significant reduction in water. So to try to rinse all of that material down the drain into the septic tank, they used a lot of water to do that. And then also had to have the tank pumped more often. So the side streaming is significantly reduced their water use on top of the septic.
Yeah, and that's because they're using that tank pressure, the head pressure in the tank, to push the materials into that tote instead of trying to just like rinse it down the drain.
Yeah.
Excellent. We still have time for more questions, so please go ahead and raise your hand or type it in if you have any more. I'm thinking long-term, a vac truck is a significant investment. And you mentioned, Jeremiah, cheese making waste. There could probably be yogurt making waste, salsa making waste, other things. What other materials are you looking at expanding to?
Yeah, so I mean, there's also food waste slurry that this truck could handle. So it's similar to what the high strength brewery waste is when it's mixed together. It has a solid to liquid ratio. I know the digester is looking for more liquid waste. So we've got one cheese manufacturer that signed up. We're talking to another one, and yeah, I've reached out to some others and haven't found the right path. Large scale producers would require a larger piece of equipment to move their waste. So similar to what we're doing here, it'd be targeting your smaller to medium size producers that have a liquid waste, as opposed to a large scale producer that would require a 9,000 gallon vac truck.
Mm-hmm. How many gallons can your vac truck hold?
It's 1,900 gallons.
1,900, that's right. Okay. And my next question is kind of out there. We have a lot of people on the call that are essentially planners or university, those. What could governments or universities do to promote a similar hauler situation, like to get this going in their own community? I mean, what was needed to put it together besides a good EPA grant?
Or what support would you need as a community in order to get something? Like how could BetterBev help support your vision?
Yeah.
That's one of those things that I would love to put together. And we were talking that NEFC was talking in our weekly meeting about regional collaboration on putting together permitting expectations for stormwater management, kind of best management practices, and aligning those processes. So when you go, across state lines, it's not a big shock, or across community lines, everybody's talking about, speaking the same language, expectations are the same. That would be one thing that I would love to workshop in thinking about kind of the pre-treatment rules and how to sufficiently incentivize best practices in a way that comes across as, more of a partnership, so that I'm always thinking about how to get brewers to tour treatment plants and understand what the heck's happening downstream, and how to get treatment plant operators and managers to tour breweries. And, once you get people in a room, regardless of how they feel about everything, right? Once you actually get people in front of each other, then that's when you actually start solving problems. And like that, it'd be a pretty minimal lift to be able to take everything that exists across the board and pick out the best parts of this process. And I don't know.
Make it happen.
Yeah.
Well, I don't see any other questions, and that's a good segue into the fact that BetterBev is still would be happy to partner with other communities. So if you're interested in seeing what we can do to help make this sort of case happen in your community, please get in contact with Luke or me. Or just do a form on the betterbev.org website, do an interest form, and let us know. I guess, and with that, thank you all for coming. This was a great conversation, great project. Jeremiah, thank you for sharing and doing all your good work on helping sustainability in this sector. It's so important.
Thanks.
Jennifer, go ahead.
I'm so sorry. I was trying to do a little react button for you
Oh, I
guys, but I
see.
hit the hi.
Oh yeah, we got it. Yeah, it's a hand. So I see. Well, thank you. I assume you're giving a little clap or shout out. So with that, I look forward to seeing you all again on September 16th. If you want to learn about how the program can help pollution prevention programs. All right. Take care, everyone.
Thanks, Jeremiah. Thanks, John.
Thanks.
See
Thank
y'all.
you.
Take care.
Bye.